Section 5.4, the integral of e to the x dx. Well, we know the derivative of e to the x is just e to the x, so the integral of e to the x dx is just going to be e to the x plus c, plus cookies. Now right here, though, we don't have e to the x, so you can do it. U is going to be 6x plus 2. Du over dx is just going to be 6 right here. So du is going to be 6 dx. Now we don't have a 6 out in front here. That's fine though. So we're going to say 1/6 du is equal to dx. So this is going to become 1/6 of 4 e to the u du. And I'm going to go ahead and kick the 4 out front here. So it's 4/6, which is really just 2/3 e to the u du. Well, the antiderivative of e to the u is just e to the u. So that's going to give me 2/3 of e to the u plus c, which I can rewrite as 2/3, once I back substitute, of e to the 6x plus 2 plus c. That is my answer right there. Next problem, same sort of thing. It's not just e to the u right here. 4 pi x e raised to the negative 5x squared. Well, let's try u is equal to negative 5x squared. Du is going to be negative 10x dx. Now, I don't have the negative 10 out here, so let's just slip this over to this side. Negative 1/10 du is equal to x dx. X dx right there. Excellent. We're also going to slip this 4 pi out front. So we're going to get 4 pi. The x dx, of course, becomes just the du over negative 10. And we're going to have e to the u. I can reduce this to 2 pi over 5 with a negative out front. And the antiderivative of e to the u is just e to the u plus cookies. And we're going to get negative 2 pi over 5 e to the negative 5x squared plus c, once I back substitute. Next problem, you may want to try this on your own first here. I'll give you a second here to pause the video, try it on your own, and then you can check with the video. Alright, so if you paused to try it on your own, let's see how you did. I'm going to make u equal to 5 over x, which is really 5x to the negative first. So du is going to be, bring the derivative down, negative 5x to the negative second. Which, once I change this a little bit, negative 1/5 du is equal to x to the negative second dx. You may say, I don't have an x to the negative second. Of course we do. It's right here. I could rewrite the original problem as e to the 5 over x. That's x to the negative second dx. So this right here is going to become my du, or the negative 1/5 du. And this right here is just my u. So this is going to give me the following. Negative 1/5 e to the u du. Negative 1/5 e to the u plus c, negative 1/5 of e to the 5 over x plus c. Moving on to the next one. This one's actually a little bit different. The derivative, remember, because this is undoing the chain rule, the derivative of whatever u is has to be multiplied by the dx. So I can't just use x right here because that goes away. U in this case is actually going to be 17 minus 4 e to the x. I'll let you pause right here since you know what u is now. Give it a shot. Alright, assuming you pause the video, you can check with mine right now. Du is going to be negative 4 e to the x dx, or negative 1/4 du is equal to e to the x dx. So this is going to become, I'm going to kick this 3 out front here. It's e to the x 17 minus 4 e to the x dx. Well, this part right here is my negative 1/4 du. This is my u right here. Now, you'll notice I am dropping the limits for the time being. That is fine. I can if I want to plug them in here. If I were to plug them in here, 0, plug in right there, that's going to give me 1. So 17 minus 4 times 1, we'll go ahead and use them. And that's going to give me 13. If I plug in 2 here, it's going to be 2 in for the x, it's going to be 17 minus 4e squared. That's my other limit. This right here is my negative 1/4 du. I'll bring in negative 1/4 out front here. And I'm going to have just 1 over u du. Now this is a little bit different though. I've got 1 over u. Well, what's the antiderivative of 1 over u? It is the natural log. So it's going to be the natural log of u. And negative 3/4 of that. Now we don't have the plus c because this actually has limits on it. So we're doing this with 13 and 17 minus 4e squared. And that's going to give me the following number. Negative 3/4 natural log of 17 minus 4e squared. Minus negative 3/4 the natural log of 13. So not a pretty number there, but it's what actually happens. Last problem here. E to the x cosine of e to the x dx. Got to integrate this. No problem. Once again, whatever u is, the derivative of it has to be multiplied by the dx, because that's the chain rule. Well, u is going to be e to the x. So that means du is going to be e to the x dx. Oh, it's right there. So my new function is going to be the cosine of u du. Let's plug in our limits here. Negative 1 into e to the x is going to be just e to the negative 1, or 1 over e. If I plug in 0 in for x right there, that's going to give me just 1. What's the antiderivative of cosine? Sine. You're absolutely correct. The sine of u. And I'm going to plug in the limits 1 and 1 over e. So my answer is going to be the sine of 1 minus the sine of 1 over e. There we go. Thanks for watching. I'm sorry about that. I realized I didn't shift the paper off to the side. Here's the rest of the work so you can look at that. And now, thanks for watching.